Welcome to my class. In this particular video, we will talk about normalization of RDBMS, Relational Database Management System. Meaning of normalization. Normalization is a step-by-step decomposition of complex records into simple records. What is the objective of normalization? Normalization reduces the data redundancy in the database using the principle of non-loss decomposition. If we want to understand the objective of normalization, then we need to know the meaning of data redundancy and non-loss decomposition. Let us try to understand the meaning of data redundancy and the principle of non-loss decomposition. Data redundancy. The term data redundancy means unnecessary repetition of data. If there is data redundancy, it causes 4 problems. These problems are termed as 4 anomalies. The first one is repetition of data increases the size of database. Second is insertion anomaly. The third one is deletion anomaly. The fourth one is updation anomaly. Repetition of data increases the size of database. Here you can see it in this particular table. The information in column 4, it gets repeated in every row. The same color shows that it is a repetition of information in column number 4. We can see in the student table, we have number of fields, roll number, name, course, name of HOD and HOD mobile number. In this particular case, we see that the field course gets repeated in number of rows. Similarly, the name of HOD and the HOD mobile number, it gets repeated number of times. If same information is there, then it increases the size of database unnecessarily. The memory size increases. Number of times this data get repeated. In the field course, name of HOD and HOD mobile, the same information gets repeated in number of rows. The second is insertion anomaly. Now look at in the same table, if we entered once again VCA in the course field and in the name of HOD again RK Gupta and in the HOD mobile the same phone number, in that case it is termed as insertion anomaly. What is exact insertion anomaly? To insert redundant data for every new row. If we are inserting redundant data for every new row, as you have seen it in the case of student table, then this insertion of redundant data in every new row, it is a data insertion anomaly. So if we already enter data in every new row, then it leads to insertion anomaly. Deletion anomaly. We will continue with the same table. We have field roll number, name, course, name of HOD and HOD mobile. Now look at in this case, if students leave the college in between and his records must be deleted. If all students leave this course, then their records are deleted and unintentionally information regarding the name of HOD and his mobile number is also deleted. So in this particular case, if all these students leave the course, in that case we will delete the record of these students. With the result, the name of HOD and HOD mobile number, it also gets deleted, which we don't want. So this is termed as deletion anomaly. We are deleting the information of student, but accidentally we find that information regarding the name of HOD and the HOD mobile, it also gets deleted. The next is updation anomaly. We will continue with this same table and we will see that what is updation anomaly. If Mr. R.K. Gupta leaves the college for some reasons and new teacher joins, then changes must be made in all the rows. We will make changes in the name and we will make changes in HOD mobile in all the rows. A new teacher, Mr. Ajay Singh, joins, then changes must be made in all the rows where name and mobile information is. If a change is not made in one particular row or one particular column, then it leads to updation anomaly. If information in a single cell is left unchanged, it shall lead to data inconsistency in the database, and this is termed as updation anomaly. Therefore, data redundancy leads to memory storage problem. It increases the size of the database. Second is insertion anomaly. The third one is deletion anomaly, and the fourth one is updation anomaly. The next point is principle of non-loss decomposition. Non-loss decomposition refers to division of big table to smaller tables without loss of information. Here we have a table, student table. Student table has got number of fields. The first one is roll number, then name, course, name of HOD and HOD mobile. In this case, we will divide the student table into two smaller tables. We can look into this particular table. Now this is a new student table in which there are three fields, roll number, name and course. We have second table, HOD table, in which we have three fields, course, name of HOD and HOD mobile. But in this case, the name of HOD and HOD mobile number appears only once. In the new student table, we see that the course gets repeated again. One can say that course information is still get repeated. Yes, normalization reduces data redundancy and not eliminate total data redundancy. So the purpose of normalization is to reduce data redundancy, but it does not totally eliminate complete data redundancy. Thank you very much.